Hello, I am Professor Sachin Sambhaji Patil. I welcome to all of you for this session. So today we are going to see synchronous optical network. Once again, I welcome to all of you for this session on SONET, that is synchronous optical network. So what is SONET? So SONET stands for synchronous optical network. So synchronous optical networking, SONET, is a standardized digital communication protocol that synchronously transfers multiple data streams over longer distances through fiber optic cables. So, what is a synchronous? Synchronous means time matching. So, we are transmitting data at same time. Okay, multiple data means more than one data streams over a longer distance. So what do you mean by protocol? So protocol, it is a set of rules used for data transfer between two entities, is called as protocol. So what is the SONET? Stands for synchronous optical network. So SONET is a communication protocol developed by Bell Core. So that is used to transmit a large amount of data over relatively large distances using optical fiber. So that is used for large amount of data transmitting over a longer distance using optical fiber. So it is a physical layer specification that allows simultaneous transmission of voice, data and video. So these are the nature of information. We are transmitting at a speeds of as 1 Gbps, 1 gigabits per second through a single fiber. So SONET was standardized by the American National Standards Institute (ANSI). It is equivalent to synchronous digital hierarchy (SDH) standardized by the International Telecommunication Union, that is ITU. So what is the SONET frames? So SONET frames consist of 9 rows, 90 columns. So we can see here in this 9 rows and 90 columns. So first 3 columns indicating system overhead and remaining 87 column is indicating payload. So 9 rows multiply 90 column, that is a structure of one frame, and we are getting 810 bytes. So one block consists of 8 bits. So that's why 9 rows multiply 90 column, that is the structure of one frame, SONET frame, that is 810 bytes multiply 8 bits. 8 bits means one block containing 8 bits. So such kind of how many frames are there in 1 second? That is 8000 frames per second. 8000 frames per second. So frame rate is 51.84 Mbps. So frame rate is 51.84 Mbps. That is the we are getting 51.84 into 10 raised to 6 bits per second. So that is a frame rate. Okay. So what is the SONET frames, which can consist of 9 rows, 90 columns. First 3 columns is for system overhead, then 87 is for payloads. So we can say the SONET frame comprises of a block of 810 bytes. The frames are transmitted at the rate of 8000 frames per byte, which is the sampling rate of the telephony networks. A SONET frame is represented as a rectangular block of bytes with 9 rows and 90 columns. So SONET frame consists of 9 rows, 90 columns, so 810 bytes. So one block containing 8 bits, and how many frames are there? 8000 frames per bytes. That is, we are getting 8000 frames per second. So after doing this calculation, we are getting the frame rate is 51.84 Mbps, 51.84 into 10 raised to 6. Okay. So this is the SONET, synchronous optical network. So what is the SONET? It is the synchronous optical network So synchronous optical network, which consists of three different connections. So we can say these are the terminals which are connected to STX mux demux, then regenerator, add drop multiplexer, regenerator, STX mux demux, and these are the terminals. So two connection between these two neighboring devices is called as section. Okay, the connection between mux and regenerator is section 1, 2, 3, 4. The connection between the neighboring multiplexer is called as line connection, and the connection between two entity STX mux and STX mux is called as path connection. So what is section connection? Connection between two neighboring devices is called as section connection. Connection between two neighboring multiplexer is called as line connection, and the connection between two entity STX synchronous transmit signal mux and synchronous transmit signal mux is called as path connection. Okay, so we can see the SONET devices are connected to each other by section, line, and path. A section is defined as optical link that connects two neighboring devices such as multiplexer, regenerator. So we can see here section is nothing but the connection between two neighboring devices. It may be mux, regenerator. Okay, this section connection. This is connection between this regenerator at drop multiplexer section. This is again section connection. Okay. So what is connection between these two multiplexer is called as line connection. So we can see here this is line connection. This is one multiplexer, STX multiplexer, and this is the add drop multiplexer. So this connection is called as line connection. This connection between add drop multiplexer and this multiplexer is called as line connection. Okay, and this is a section connection, connection between two neighboring devices, section connection. This also section connection, regenerator and add drop multiplexer, this section connection. This again is section connection, and this also section connection. This is line connection between two multiplexer. Okay, this line connection. And what is path connection between the two entity? It's STX mux and this is the demux. So the path is defined as end-to-end portion of the network between of the two STX multiplexer. So we can say this is the multiplexer, STX multiplexer, STX demultiplexer. So these are connected using path connection. Okay. So STX multiplexer role is there, performs multiplexing of signals, converts electrical signal to optical signal. STX demultiplexer perform demultiplexing means one signal to many signal. Multiplexing means many signal to one signal. So demultiplexer converts the optical signal to electrical signal. Regenerator means repeater, which recovering the strength of original signal. Add drop multiplexer, it allows to add signals coming from different sources into a given path or remove signal. Add means adding of signal, drop means removing of signal. So why SONET is used now? SONET is used to convert electrical signal into optical signal so that it can travel over a longer distances. It is called as SONET. So we can see in this figure, these are the signals are multiplexed together. This is section connection. This is line connection, and this is the path connection between the end-to-end devices. Okay, this add drop multiplexer is here. This is repeater. Okay, this is STS. We can see this repeater and this add drop multiplexer. This is multiplexing of signal. It may be voice, data, audio, video, like this. Okay, and so this is frames rate 51.84 Mbps. We are seeing that STS 1 frame rate. So OC 3 multiply this. OC 9 multiply this. We are getting this value. So what is this relationship between SONET layers and SONET devices? We can see here the STX multiplexer having this 4 layer, photonic, section, line, path. Okay, and regenerator, this is section connection, this is line connection, and this is the path connection. So what is the regenerator working in 2 layer, photonic section, add drop multiplexer working in photonic section, line, regenerator working in photonic section, and this STX multiplexer working in photonic section, line, path. So what is converting electrical signal to optical signal to back to electrical signal. So SONET, which is converting the electrical signal to optical signal, transmitting signal over longer distance. These are the different layers which are shown here. Regenerator working in two layers, photonic section. Okay, airdrop multiplexer working in photonic section, line layer, and okay, this is the STX multiplexer working in 4 layers. So this is the layer which are responsible for electrical to optical signal conversion, and these layers are responsible for optical to electrical signal conversion. Okay, so what is this SONET connection? So portion of network connecting two neighboring devices is called as section. The portion of network connecting two neighboring multiplexer is called as line, and end-to-end portion of the network is called as path. So we can see here the portion of network which is connecting the two neighboring devices. This is section 1, section 2, section 3, section 4. The portion of network connecting two neighboring multiplexer. So this is the STX, means synchronous transmit signal, MUX, and this add drop multiplexer. This connection is called as, that is we have seen that is a line connection. Okay, that is the line connection, and this is again line connection. The section connection between two neighboring devices, line connection between two neighboring multiplexer, this line connection is again line connection, and a path connection, it is a connection between two entity, that is the connection between the STX MUX and STX DMUX. This is called as, that is the path connection. Okay, so we have seen that what is the different SONET frames rate and what is the SONET frame structure. Okay, then we have seen the synchronous optical network connections, how they are connected SONET devices using section, line, path. So section is nothing but the connection between two neighboring devices. This 1, 2, 3, 4 section connection. Connection between two neighboring multiplexer is a line connection. We can see here, this is line connection. Okay, and the connection between two STX MUX and DMUX entity is called as path connection. So how many section connections are here? 1, 2, 3, 4 section. How many line connections? This is the connection between two neighboring multiplexer, means this multiplexer, this add drop multiplexer. One line, second line. How many path connections? Only one path connection. So section connections are 4, 1, 2, 3, 4. Line connections are 2, 1, 2, and path connection is only 1. Okay, so I am very thankful to all of you for watching this video. Keep watching, and please like my video, subscribe my channel. Okay, thank you very much.